DTMF transparency test calling from VoIP to legacy phone network. You might have problems that DTMF does not work well in some occasions. You might check if you made mistake from the description below. In the VoIP world of SIP and RTP, if we generate DTMF signal and encode it as we deal with voice, it is called sending DTMF in-band. It is known that in-band DTMF can only be employed when G.711 MULA or ALA is used. In-band method usually does not survive after speech coding. However, RFC 2833 might not work well because the corresponding RTP payload type is not supported. In this case, there is no choice but to go back to in-band method. DTMF method can be chosen at phone basic SIP setting. There are 4 options: RFC 2833 SIP info in-band, RFC 2833 or in-band. We can check the box RFC 2833 or in-band as shown in the following diagram. Colored-Ringback. Some telecom service providers will use music and advertisement announcement messages to replace ringback tone. This is known as color-ringback. If it is not desired, the box forced to regenerate ringback tone can be checked during the setup of SIP trunk phone cascade SIP trunk. If color-ringback is used from the other side, the system will send 183 session progress for indicating early media so that color-ringback tones can be heard. However, the system is acting as back-to-back user agent. It does not support 100 rel. Overview of T1/E1/J1. Note, those TDM cards are from third-party vendors. They might not be available. The system can also bridge the legacy telecommunication interfaces like T1 and E1 to VoIP world. In the following sections, we will introduce how to configure it for use. We only cover the voice application over T1/E1 in this manual. A T1 trunk consists of 2464 kilobytes per second channels and operates at 1.544 Mbps. It is usually used in North America. In our scenarios here, it is used for voice communication. The most common voice signaling method in North America is ISDN-PRI. It is with 23 voice data channels, so-called B channels, and 1 channel for voice signaling, known as D channel. Usually, we use 24 channels for signaling. This is also known as out-of-band signaling. It means signaling is done outside the channel itself. It is done in a separate channel. T1 can also use in-band signaling so that 24 channels can be used for data. However, each data channel is going to be robbed from 64 kilobytes per second to 56 kilobytes per second for signaling. In-band signaling is usually used with channel bank to emulate analog signal. It is difficult to support many features. The standard frame of T1 is 193 bit long, 1 framing bit plus 24 x 8 bits, and each time slot is scanned 8000 times per second so that it operates at 1.544 Mbps, 193 x 8000. Those framing bits are used in a different ways to ensure synchronization. There are 2 formats of it: superframe, D4 framing, and extended superframe, ESF. To avoid loss of synchronization while there are long succession of zeros in the data, T1 has the schemes to use data itself to synchronize instead of using start/stop bits to save overhead. The line coding of T1 is devised for synchronization or clocking. There are 2 types of line coding in T1, AMI, alternate mark inversion, and B8ZS, bipolar 8 and 0 substitution. AMI is usually used with D4, SF, and B8ZS is usually used with ESF. However, AMI was found to be spectrum unfriendly, that it could radiate some energy to interfere with the other electronic devices. But it is still used in some rural areas. Similar to T1, E1 is used in Europe. It has 32 channels versus 24 channels in T1. For PRI signaling, it is with 30B plus 1D, and channel 16 is always used for signaling and the other channel is for synchronization. E1 operates at 2.048 bit/section. E1 has also in-band signaling, but it is still with 30 channels available. Its channel 16 is reserved so that you cannot use it. E1 is using HDB3, high density bipolar 3, for line coding. NCA is used for in-band signaling over E1, CCS is used for out-of-band signaling, like ISDN-PRI, or SS7, on E1. J1 is used in Japan. The difference between T1 and J1 is mainly on the condition to send out yellow alarms. Thus, it can be configured in the same way as T1. For voice signaling over T1/E1, it can be classified in this way: loop start, ground start, ENM and its variants, wink start, feature group B, feature group D, and MFC/R2, on E1 only, belong to in-band signaling. PRI and SS7 belong to out-of-band signaling. To use out-of-band signaling on T1, you need to specify D channel. On E1, you need to specify CCS on framing. To use in-band signaling, you do not need to do anything special on phone basic TDM, T1/E1, for line interface setting of T1, but on E1, you need to specify CA on framing setting. To ensure reliable transmission, T1/E1 requires system timing clock to function. This system timing clock source can be from network side, through the incoming frames, or the local side of the system. To connect two machines together for back-to-back testing or loop-back testing on T1/E1, you should prepare crossover T1 cable with RJ45 connector as shown in the following diagram. The transmit pairs, TX plus and TX, need to connect to the receive pairs, RX plus and RX, on the other end. Please note that, although the connector is the same as Ethernet, RJ45, in the system, the crossover wiring is different from Ethernet. We are going to introduce how to configure the system in the following sections. T1/E1 hardware setting. We start with the setting on the T1/E1 interface card itself. On the T1/E1 interface card, SW1 is for selection T1/J1 or E1. For using it in E1 mode, set as follow, the 4 jumpers 1, 2, 3, and 4 should be on the up position. For T1 or J1 mode, put it as follow, the 4 jumpers 1, 2, 3, and 4 should be on down position. For SW2, it is used to identify the card when you have multiple T1/E1 PRI cards on the server. If you have 2 cards together, use 0 for the first card and 1 for the other. If you have 4 cards, use 0, 1, 2, and 3 respectively. SW3 is used for setting hardware echo cancellation. There are 2 directions to cancel the echo as the diagram indicated above. One is for local user, the other is for remote user. To remove the echo for local side, user 1, put the switch as follow, the jumpers 1 and 2 should be away from the position on. To remove the echo for far end side, user 2, set the switch as follow, the jumpers 1 and 2 should be toward to on. Those are the jumper setting on the interface card itself. Once those items are finished, we can move on to the web management interface to configure the system. T1/E1 line interface setting. As we mentioned earlier, T1 has 24 channels and E1 has 31 channels for configuration. On the bottom of the screen phone basic TDM, T1/E1, we will see how many channels are available in a span. If it has 24 channels, we know that the hardware setting makes it in T1 mode. If it has 31 channels, it is in E1 mode. If it is empty with no channels shown, the interface card might have been broken or the T1/E1 interface card is not detected at all. The following diagram is an example that there is no T1/E1 card detected in the system because the content of the square box on the bottom is empty. The channels associated with span number are shown on the bottom dialog box. So, it is quite straightforward to start with configuration for span number. For timing source, if your T1 line is coming from telecom operator, you should always set to from remote side to use the signal from telecom operator as your system clock timing source. However, if you are use T1 crossover cable to connect 2 machines together, one should be set as master for the system clock timing source and the other is to be set as from remote side. If the system clock timing source were not configured properly, the connection would be unreliable so that there might be noise or glitches in audio. Line build-out is to specify signal strength along with the length with T1 line. Under the framing item, D4, superframe, and SFrame, extended superframe, are used for T1, CA, channel associated signaling, and CCS, common channel signaling, are used for E1. To sum up, we have the following fields to set on phone basic TDM, T1/E1, span number timing source line build-out framing line coding. Non-facility associated signaling, NFAS, non-facility associated signaling, is only used for T1. It is binding multiple T1 lines together as a trunk group and sharing a common signaling channel, D channel. For E1, it always includes the processing for signaling time slot so that NFAS is not used with E1. The following is the screen snapshot at phone basic NFAS.